All right, good afternoon, everybody. How's everybody feeling? Yeah? Haven't crashed from the lunchtime meal yet? That's good. Make sure you get that coffee during the breaks. Um, my name is Ben Smith. I work for Pivotal Labs here in Boulder, and this is where I tweet. Please feel free to tell me I'm crazy on the internet, and if you don't think I'm crazy yet, wait 10 minutes. I'll try my best to convince you of that. And I'm here today to talk to you guys about Rails architecture for a big Rails app that I built. But first, I'd like to take a little detour to talk about something else. I'm a fairly new conference speaker. I've only been speaking for the past year. I've got to do a lot of traveling. I've spoken all over. And when I got accepted to Rocky Mountain Ruby, I was super excited. It was my hometown. I felt like I'd get the hometown advantage, and this would be an easy conference for me. But today, I started getting really nervous. And at first, I thought, it's because I'm wearing shoes. I usually wear flip-flops, so I go barefoot, so I took off my shoes. But that didn't help. I was still nervous. And I realized it was because the people in the audience I know, they're my friends, my coworkers, old clients, current clients, future clients possibly. There's people in the crowd that I know are way smarter than me. They're my mentors. They're people I look up to. And this made me realize that everybody looks up to someone, no matter who you are. There's someone else out there that's looking up to you and is inspired by what you do. And what does this mean? It means that someone's looking up to you, and you need to be amazing. And when that person who looks up to you comes up to you and starts a conversation, like at this conference, be a mentor and help them any way you can. And this stands for Mats is nice, so we are nice. And that's something that I love. And I think that, at these conferences that you go to, be nice to everyone. Help everyone out. If someone comes up and talks to you, tell them everything you know, and just be outgoing and helpful with everyone. So that was my slight detour. Thank you for listening to that. So back to the real talk. How I architected my big Rails app for success. So this is architecture talk, and you might say that Rails has its own architecture. And I'd agree. It does use a design pattern that we all know and love called MVC biscuit. But once your app gets big enough, relying on just the Rails way of doing things might get you in trouble. So I'm going to tell you a story about a Rails app that we tried our best to architect for success. And what does success mean for a Rails app, for a product, for a client? Well, in this case, we knew that the engagement was going to be fairly long. It was going to last 8 months or longer, which at Pivotal is a big chunk of time. Most of our projects last 3 to 6 months. We knew we were going to have a big dev team that was going to ramp up to 10 Rails devs and 4 iOS devs. And in 6 to 8 months, we knew we'd just end up with a ton of code, given the number of devs. This particular project was a from-scratch rebuild as well. And the client wanted their existing code base and tool set replaced. And we knew to get feature parity with their existing tools, we'd just end up with a lot of code. The client also wanted to make sure we had scalability in mind. Not that it needed to handle 1 million requests per second day one of launch, but that it was built in such a way that it could get there eventually. And the last thing they wanted was they wanted a big bang release. So they wanted to replace our old code base all at once. And this isn't something that we normally recommend, but we worked with them hoping that we could release sooner than when it's all done. So what does success look like in these terms? Now, normally I'm all about doing the simplest thing possible, so I suggest you take this talk with a grain of salt. What I'm going to show you today is not a silver bullet. It will help you in some cases, but in other cases, it will only make things more complicated. And I'm not an expert on this subject. I'm just somebody who tried a few things, and this is my experience. So success. With these constraints, we knew we wanted to think about architecture from day one. And the first decision we made was to use Rails engines. Kinda. we decided to use engines, but not in the normal way you see them used. Who knows what a Rails engine is, first off? Just about everybody. I'll just explain it really briefly for everyone else. A Rails engine is an entire Rails app that you bundle together and can reuse. So this includes models, views, controllers, CSS, JavaScript, everything. You can bundle all that together and reuse that as a dependency. Devise is a great example of an engine. Devise is built into a gem, and this can be included in your Rails code base, and you get views, models, you get database tables, you get everything. So we were using these engines, but unlike Devise, all of our engines were never built into gems. They were never pushed to Ruby gems. Not only that, they never even had their own Git repo. All the engines we created went under our normal Rails source tree, which meant for all you SOA advocates, we didn't have to worry about versions of interfaces or separate deployments. All the engines I'm going to show you in this talk lived inside a single Rails app, and we deployed and versioned that single Rails app just as one. They weren't separate apps at all. Of course, you might ask, why use engines in the first place? And we decided earlier that there was a few distinct components to our app that we could section off chunks of code into. And let me give you a little background on the product so you can understand why. The product itself is a content publishing platform for videos, audio, blog posts, Facebook posts, tweets, all types of things. And on top of that, it included a full social network. And the content was published and consumed by an iOS app fed by a JSON API. And the content was created and moderated via a web interface. So that domain doesn't seem too complex at first glance, but we are focused on architecture. So we took our simple Rails app and started to break it up. And in this diagram, you can see we have our Rails app, and inside of it, we have 4 engines. And the arrows point in the direction of the dependencies. And I'll refer to this main kind of wrapping Rails app, this big box here, as the wrapper Rails app from here on out. So over here, we have an admin component where content gets created, videos are uploaded, blogs are written. On the other side, we have the social network. This is a user-facing content in the form of a JSON API. At the bottom, we created a common engine. This is where we put things like users and roles, things that were required by both the admin engine and the social network engine. And at the top, we have another engine called the scheduler, and this engine was in charge of publishing content. So the admin could create content and would get copied over to the social network or published to an external web service whenever it was scheduled to go live. And going forward, I'm not going to draw the box around the engines. Just assume that all of these engines that I'm going to show you are within a single Rails app. And remember, the arrows point in the direction of the dependencies. So the scheduler depends on the admin engine, the common engine, and the social network engine. The admin engine just depends on common, and common doesn't depend on anything. Does this example make sense to everyone? Because it's about to get quite a bit more complicated. So the next thing we did was we wrote a gem to wrap a SMS service called Mobile Compass. We chose to make this a gem instead of an engine because it didn't need a database connection, the asset pipeline, or anything else that Rails gives you. And I made Mobile Compass red here to show that it's a gem and not an engine like the rest. And I don't know, it's kind of hard to see with the colors, but we wrote a lot of code in this architecture with just these 4 gems, or just these 4 engines and a single gem. But as we got farther, we started identifying users of the system we could create specific engines for. We realized that there's 2 types of admins: a global admin who could CRUD users, and a content admin whose sole purpose was to create content. So we broke these into 2 separate engines, and they both depended on an admin assets engine. And admin assets just contained layouts and styles that both the admin engines used. And once we realized it made sense to split out engines for each role of the system, we created another admin engine called the social admin. And the social admins were moderators of wall posts or status updates or any other user-generated content. And we felt pretty good about this. We were identifying engines, and we were keeping our app split up into smaller pieces. Then we had a breakthrough. And it actually wasn't us. It was our office director. Some of you might know him, Mike Baranek. That's not a picture of him. He walked by and he said, "Your social admin engine depends on too much. It doesn't need a dependency on things like the controllers in the social network engine. All it needs are the models." Now remember, the social network engine is the user-facing JSON API, and the social admin is the web interface to moderate things like wall posts and status updates. The models for wall posts and status updates lived inside of the social network engine. And it took me a while to come around to this idea, but he did have a point. The social admin engine depended on all of the social network engine, which means it had reference to things like controllers, which just weren't needed. And keeping your dependencies to a minimum is always a good idea. What we really wanted to do was just depend on the models of the social network. This would allow us to create controllers around wall posts and status updates to moderate them. So we went back to our engines and we did a refactoring, and we pulled the models out of the social network and put them in an engine called social network content. We renamed social network to social network API because now it truly only contained API code, just controllers and JSON presenters, no models, no domain logic. And finally, we added a dependency from the social admin to social network content, which, going back to the original problem, allows the social admin to only require what it needs. So instead of having this, we have something that looks like this, which addresses the problem of requiring too much. But we realized, why stop there? We realized that the scheduler engine had the same problem. It was requiring the content admin engine, and all it needed was the models inside of that engine. So we split that out into a content admin element engine. We updated the dependencies to reflect that refactoring. And at this point, we started to notice a pattern. We noticed that some engines could respond to HTTP, ones that had controllers and routes. And we had other engines that only contained models or business objects. So we started calling them web engines and domain engines. And here I've color-coded them. So you can see web engines are blue, domain engines are brown. And as a team, identifying these patterns and putting names to them is super helpful. Once you identify a pattern and name it, now you can think in terms of what makes sense for that given pattern. For example, if someone said, let's add a user's controller to the common engine, I could say, no, that doesn't make sense because it's the domain engine. But speaking of a common engine and of patterns, we realized that having an engine named common is a really bad idea. Common means you can put whatever you want in it. It's like the lib folder in Rails. You can throw whatever you want in there and it's fine. So we renamed it to be what we wanted it to be, users. And once we did that, we realized there was stuff in there that shouldn't be in there, specifically a profanity filter. So we pulled that out into an engine. And from here, we did some more work and some more work. And this is where we ended up after about 6 months of development. And we kept working on the app, but it just keeps getting more complex and crazy and harder to draw, so I'm going to stop right here. How does this look? Impressive? Crazy? Thumbs down. No good. So it's understandable when you look at this that you say, this is insane. There's no way I could work in this. But drawing this diagram isn't a complexity that's added because of engines. This is a complexity of the app, not because of engines. We would have these same dependencies if we didn't have engines, but we wouldn't be able to talk about them as easily. And the reality, when we were working on this app, you didn't need to know the entire graph by heart. You just need to know the part you were working in. So you could focus in and understand one subset of the graph, and you'd be fine there. And in general, there's a pattern to these engines. The general pattern for these engines is that the web engines at the top would depend on domain engines underneath them, which would depend on the database. And if you think about that, that's not far from the Rails stack, which just is controllers and views depending on models, depending on the database. So really, this does look scary, but it's not far off from your standard Rails stack. And if you don't believe me, now is the time to go tweet at this handle and tell me I'm crazy. All right, so now that you've seen where engines can get you, you're probably asking yourself, How do I get started? How do I get into this crazy world of engines that you've just shown me? One of my pet peeves with other architecture talks is that they rarely give you real steps to get started. So I'm going to give you some of those steps. So this is how you create a Rails engine. You run this from within the root of your Rails app. And don't worry, I'm going to post all these slides online so you don't have to take pictures or notes. In the gem file, you add this line which creates the dependency to your newly created engine. And of course, you can add a dependency from a wrapping Rails app on an engine or from one engine to another engine. And the last thing you need to do is mount the engine if it has routes and controllers. And this is only if you have a web engine, right? If you want to create a gem, it's just about as easy. This is how you create it. This is how you require it. And then the next thing you want to do, once you've played around with these things, once you've created a few gems and a few engines, is instead of running this command every time you need a new engine, you run it once and you create an engine template. And from there, all you need to do to create a new engine is copy and paste that engine template. And from there, you do a global find and replace on a couple of strings, rename a couple of files, ideally from a script you write. And this gives you a standard base template to work off of. And so if you want to include some basic dependencies like rspec or haml, you can do that from within your template. The same thing applies for plain old gems. You want to create a template that you can easily reproduce gems off of. You really want to lower the bar for creating these engines and gems to the point where it's a couple of minutes tops to create a new one. What we found was it's much easier to decide to merge code together rather than split it apart later. So if it's very easy to write code that's already split apart, then people will be more likely to do it. Your developers will be more likely to do it. So you guys got all that? The slides will be posted online. Don't worry about understanding all that yet. Let's go back to talking about some interesting stuff. So from the beginning, we decided that engines should be completely self-contained. And what that meant for us was that all the database tables were namespaced, all the migrations lived inside the engines, and the tests were run within only that engine, not within the entire Rails app. So let's talk about each of these. With this architecture, we wanted clear and real boundaries. We wanted boundaries almost as real as you'd have with full SOA. So if you took our simple week 1 architecture and you converted it to SOA, it might look like this. And this is what we wanted to mimic: messages over HTTP, separate databases, and different Rails apps. But we wanted things easy. We wanted a single Rails app, one database, and engines instead of, or messages in Ruby instead of over HTTP. So we took our Rails engines with its single database, and we chose to namespace all the tables in the database. So each table was prepended with the name of the engine it belonged to. So moving from this to this would just mean pulling each engine into its own wrapping Rails app, breaking out the database tables by namespace, and adding a small wrapper so you can send HTTP messages rather than Ruby messages. The other thing we wanted to do with our engines was keep the migrations inside of them. And the interesting thing here is Rails doesn't fully support this out of the box. It does support it, but not for the use case that we wanted. Devise, you install Devise as a dependency, as a gem, and you run a rake task that copies all of the migrations out of that engine, out of Devise, into your main app, and then you can run your migrations, that's fine. But for us, all of our engines were constantly changing, and running this every time we had a new migration in one of the engines was a pain. So we chose some monkey patch Rails so you could leave your migrations inside of your engines, and this is how it works. There's a blog post, you can read about it. Not super interesting, but it's something that is slightly deviates from the standard path of Rails engines. The last thing we did with migrations is we made sure that each migration only touched one database table. And this might seem like an arbitrary constraint, but when you start working in an architecture like this, if you decide you wanted to move an entire database table from one engine to another, which is kind of a crazy thought, moving like a database table from one service to another service, if you're using this architecture and each of your migrations only touch one table, To move that table, all you have to do is copy and paste all of the migrations for that table into another engine, rebuild your test databases, and everything works fine. And here's the blog post that talks about that. The final self-imposed constraint we put on engines was testing them in isolation. And what this means is that the tests for an individual engine's functionality live inside of that engine. And when the tests run, they only require the one engine they're testing. And this proves that the engine is self-contained. It doesn't use anything that's not explicitly required. So for example, if you put your tests for the admin engine inside of the engine itself, then you can prove that there isn't any code in the admin engine that, say, references the social network, where there's not an explicit dependency. If you leave all of your tests in your wrapping Rails app, you can't prove that because everything's loaded at once. So going back to doing engines the right way, these were the things we felt were necessary for keeping everything inside of each engine clean. But outside of each individual engine, we came to some conclusions as well on how engines should interact with each other. Not having circular dependencies was key for us. Having circular dependencies makes it much harder to refactor things later. And if you look at our dependency diagram, you'll notice that there's no circular dependencies here. It's a directed acyclic graph. And if there is a circular dependency, it's because I drew it wrong. As a general practice, we decided that whenever it seemed impossible not to have a circular dependency, it meant we were trying to split things out too much. So if you had two engines and A needed to depend on B and B needed to depend on A, then probably what you wanted was a single engine that was A and B combined. But whenever you can avoid doing this, you should. And in Rails, it's super easy to create circular dependencies. Something like this is super common. User has many posts, and post belongs to user. That seems totally normal. That's the Rails way of doing things. But it makes it hard to refactor once your app gets big. This would result in a circular dependency between users and posts. So how do you avoid falling into the circular dependency trap? Well, you could stop using ActiveRecord associations. How do you stop using ActiveRecord associations? Well, you could stop using ActiveRecord. We didn't quite do that, but we did something along those lines. The approach we took was to create a domain API layer or a service layer. It's just a layer between our controllers and models that was an interface to our domain logic. And all these they're simple Ruby classes that wrap ActiveRecord calls. The arguments to these methods are just take IDs or params, really simple. And the output from these methods are plain old Ruby objects. So let's take a look at an example. So here's a simple example of a domain API class called the user manager. And in this user manager, we have a method findUserById that takes an ID and finds a user. And to do this, it calls userRecord.find. And userRecord is an ActiveRecord class. And you'll notice that this class is defined below the private line within the user manager, meaning that it should only be used within the user manager, nowhere else. The ActiveRecord user is then passed to user.new, which just copies all the attributes off of the ActiveRecord object and onto itself. Then we could return the ActiveRecord object here. But what we wanted to do was deter people from using ActiveRecord as much as possible. If you return the ActiveRecord object, then people can call user.updateAttributes or user.posts, and it would be much more appealing to use those ActiveRecord methods, and we wanted to avoid that. And this is a really simple example. The copying over attributes, you probably want to do that with a little bit of metaprogramming maybe. You probably want your user class to use active model or active naming so you can get the URL and form helpers that Rails gives you. But in general, this is the design pattern we used. And it's a brand new design pattern that I came up with. It's called the Ben's Awesome pattern. So please tell all your friends about it. This isn't anything new. So how does that help us with this situation? In this situation, there's two possible things we'd want to do. We have a user and we want to know the post that that user wrote, or we have the post and we want to know the author. So if we were to write a domain API to handle those two cases, it might look like this. In the first case, we have a user. And if we have a post manager, it'd be easy as creating a find all by user ID. And with this method, we could new up one of these post managers and call postmanager.findAll by user ID and pass it the user ID. And this handles the case of knowing the user and wanting the post. And if we have that, we don't need this line. User no longer has a dependency on posts. To get the post for the user, we use the post manager, not the user. Now, if we start using the user manager, we should be able to do something like this. New up user manager, and given a post that has a user ID attribute, find me the author of that post. Now, the crazy thing here is now we don't really have any code dependency between these two objects. There is some sort of dependency here, though. Post has a user ID. But the important thing is there's no circular dependency. And the great thing is, when we added post to our system, the user object never had to change. So when you add comments or videos or whatever else to the system, once again, the user class will never have to change to accommodate those. And who's seen Rails apps that have user classes that are hundreds or thousands of lines long? Yeah. This pattern completely avoids that. Instead of having a few huge God classes, you just have a bunch of small classes that are loosely coupled and easy to refactor later. So how does circular dependencies, or the lack thereof, affect our engines? Well, reducing the number of circular dependencies lets us go from this, a single Rails app where everything references everything else, to this, everything broken out into engines and one-way dependencies. Because like I mentioned before, if there's a circular dependency, then you should probably group those two things together. And if you have a lot of circular dependencies, it's much harder to break things out like this. The other great thing you can do with engines and an acyclic dependency graph is you can write a fast and smart test suite. Imagine you're working with an architecture like this, and say you're making changes to the admin engine. When you run your tests, you don't need to run them for all of the engines. All you need to do is run them for the admin engines, or the admin engine, and the test for the scheduler. Because potentially, the code that you changed in the admin engine could have broken something that the scheduler used. But you don't need to run the test in the common engine or the social network. There was no code changes there, and there's no code changes to things that they depend upon. So from this, you can write a smart test suite using something like get what changed, which lists the file that have changed since your last push. So you can determine which engines have changed and what engines need their tests run based on your dependency tree. And what we found is normally you only need to run a fraction of the tests. And we have our one-way dependencies to thank for that too. Because as I mentioned, things like the user engine rarely changes. Anytime we add a new feature, if we add comments, we don't need to change the user engine. And when the user engine does change, it's heavily dependent upon, so a lot of tests have to run. But something new, if we add comments to it, there may only be a couple of engines that need their tests run. So how did this all work out? How did using engines, domain APIs, and all of our other conventions work for us? Well, engines are kind of a pain. In the beginning, we had super low velocity for the first month and a half, probably. The client was getting worried, and we really couldn't bring on more developers because we were still trying to develop these patterns and best practices for using engines. Constant refactoring was required throughout the entire project. At one point, we were spending about a third of our time refactoring. And Brian talked this morning about effortful versus automatic work. And all of this stuff was effortful. This took a lot of work. It took a lot of thought. Whereas, doing standard Rails, that's a little bit more automatic. And there were some technical hurdles we had to overcome, like the monkey patching of migrations. But over the long term, engines definitely went out. At the end of 8 months, we saw no slowdown in development time. or the time it took us to do big refactorings. They also age really well. Oftentimes, we'd finish working on the engine, and we could ignore it for months at a time. It makes for super easy parallel development. You can assign a team to work within their own engine, and you don't have to worry about conflicts. And the potential for scaling is great. All you have to do is pull an engine out, put it in its own Rails app, and scale that on its own. And lastly, you can write fast tests for it. So overall, I give this architecture a thumbs up. But it probably took me 2 months to come around to it. So if this stuff seems interesting to you, or if you think it might help your current apps, give some of it a try. Try creating a new engine for the next major feature you build, or try pulling out some of your models into their own engines. Try avoiding circular dependencies, or creating a service layer. But most importantly, try to think outside of the Rails way of doing things. Think in terms of what makes sense for your app. Thanks.